Hey folks, welcome to my channel number 10. So there we have the problem on our screen. Differentiate the following. Y equals sine cube x plus cos cube x, right? So looks like this is a problem which has got the application of some rule of differentiation because we've got the function to be a sum of two functions. Function 1 is sine cube x and function 2 is cos cube x. And then within each of these functions, right, we have an application of the chain rule of differentiation because we have a function of the type f of g of x, right? And what is my g of x here? For example, in function 1, it is sine x, and in function 2, it is cos x. And then my f of g of x is a cube function, right? So let us write down what is our u and v before we go ahead and solve this problem, right? So my y becomes equal to sine cube plus cos cube, and then what is my u and v? I'm going to call my u as sine cube x and my v as cos cube x. So my y dashed, which is what I've been asked to find as per some rule of differentiation, is nothing but u dashed plus v dashed. So my y dashed, which is nothing but my dy by dx, is u dashed plus v dashed. So let us treat u dashed and v dashed separately before we come back to this step and apply the sum rule of differentiation, right? There we have our. So we know our u and v. So let's start off with u first. My u equals sine cube of x, right? Now to solve this again, I'm going to make a substitution. The substitution here is pretty simple and straightforward, and I'm going to call the variable as t in order to avoid confusion because we're already using a u and v back in the first step. So I'm going to call the function sin x as t, right? And then I know what is my dt by dx, right? Which is from first principles. Dt by dx equals d by dx of sine x, which is cos x, right? So I have my dt by dx, and then I go to my next step, right? And when I have my u equals sine cube of x, I'm going to represent my u in terms of t, right? And what is that? It is nothing but t cube, right? And why is that? Because my substitution in the earlier step is sin x equals t, right? Now I'm going to differentiate this on either side, but I'm going to differentiate it with respect to t, right? So my du by dt becomes equal to d by dt of t cube, which is nothing but 3t square, right? And drawing your attention to the formula, d by dx of x to the power n equals n into x to the power n minus 1, right? Therefore, we have du by dt as 3t square, right? Now, what do I need? I need my du by dx, right? Which is my u dashed, right? So I'm going to arrive at u dashed in the next step. So let's call out our equation, and my u dashed is nothing but du by dx, right? And what is my du by dx? I have my du by dt, I have my dt by dx. So using chain rule, I'm going to do du by dt into dt by dx to arrive at my du by dx, right? So this is what we have from the chain rule. So I have my du by dt. I'm going to highlight this, use our yellow color, and that's my 3t square. And then I have my dt by dx, which I will highlight it in green. And then I have already established what is my dt by dx. So I go back here and then put back my du by dt and dt by dx, right? And now I have a function which is dependent on x in t. I will have to redefine this function in terms of x, right? So what is my t? My t is nothing but sine x. So I'll put this back. And what is my u dashed? My u dashed is 3 sine square x times cos x, right? So that's my answer for u dashed. Now we move to the next step, and I'm going to repeat the same for v, right? We're going to arrive at v dashed, right? So let's move to step one. My v equals cos cube of x now. That's my second part of the function. So I have v equals cos cube of x. Then I'm going to do the substitution t equals cos x, right? And what is my dt by dx? My dt by dx is nothing but, from first principles, I know that my d by dx of cos x is minus sine x, right? So there I have my step one done. Now I go to my step two, where I'm going to put express my v in terms of the substitution which I just now made, which is again t cube, right? So what is my du by dt? My du by dt, we have seen it earlier when we worked out u dashed. My du by dt is again t t square, right? So it doesn't change because we have v and u similar when we have made the substitution, right? So my du by dt, I have it as 3t square. And then I have my dt by dx, which is minus sine x. So what is my v dashed? My v dashed is nothing but my dv by dx, right? So I have my v dashed equals dv by dx. So what is my dv by dx by chain rule? It is nothing but dv by dt into dt by dx, right? I have my, I'm sorry, this is dv by dt. So I have my dv by dt, let me call it with an yellow color. So I have it as 3t square. So let me pull that out. Then I have my dt by dx, which is established in the earlier step, and let me highlight it in green. So my dt by dx is minus of sine x, right? So my final answer here is minus 3t square sine x, as in my final answer for v dashed. And like we did in our earlier step, this time I will have to put back my t, but this time it is a cos x, right? So my t is cos x. So my answer for v dashed is minus 3 cos square x into sine x. Right, so there I have my u dash and there I have my v dashed as well. So I'm going to go back to the original step where we established what will be our y dashed in terms of u dashed and v dashed, and I'm going to put back u dashed and v dashed into this particular equation. So my u dashed is 3 sine square x cos x, and then my v dashed is minus 3 cos square x sine x, right? So there we are. So I have my y dashed as 3 sine square x cos x minus 3 cos square x sine x, right? So looks like I have a common factor which I can pull out. And what is that common factor? The common factor is 3 sine x dot cos x. Then I open my bracket. I have sine x in the first part of the equation, and then I have a cos x in the second part of the equation, right? I don't think we can do any simplification further. So there we have the final answer. So let us highlight it in our usual pink. Yeah. So our final answer to this problem is 3 sine x cos x into sine x minus cos x, right? I hope you found this content useful. Please do subscribe to my channel and support. Thank you.